And the chat. Okay, good morning, Marcelo. Okay, so come back to talk about, so we talk about these questions from these different perspectives, right? From these different perspective. And they, what I hope to achieve is that you guys understand what it means. Okay, instead of memorizing, a number of steps. That really is not the way to learn mathematics. Okay, so we're still focusing on these meanings and concepts. All right, so let's look at some questions in Alpha 9. Okay, we start with the first one. The first one certainly is not very difficult, but we're going to use this example to explain a lot of things. Okay, first of all, it says solve for x. Okay, the question in consideration is x squared equals to 9. Solve for x. I know you know the answer. I know you know the answer. Okay, and most of you know the answer. I hope that you know the right answer. You know the right answer. But that's not the emphasis of these questions. Okay, knowing the answer is not the sole purpose. It's to understand the meaning. It's to understand how it logically evolves into the meaning. And of course, once again, when solve for x, we know that solve for x is a shorthand notation. Okay, meaning. Okay, meaning it is if statement. It's an if statement. It basically says if a number times itself is the same as 9, what could this number be? What could this number x be? That's the meaning. We want to know all possible values that an x may assume. That's really at the core of this question. And this entire sentence is condensed into just 3 words. 3 words. Solve for x. That's the meaning. So unlike, it's just like alpha 7, alpha 8, and alpha 9, the fundamental meaning is still the same. If certain condition is given, what would be all the possible solutions? You guys hear me? To me, you taking this class, you taking all the math classes, you constantly need to remind yourself what it means. Okay? What it means. Do you follow me?
Yes.
Okay. Now, if this is true, right? So when you solve this equation, and of course I know you can guess the answer, right? You can guess the answer. That's not a problem. But understand the meaning is paramount. Okay, then we say, okay, if this is true, right? We say, if this is true, then what? Then the next will be true, which is we're going to take square root on both sides. We're going to take the root on both sides. Okay. And then what? Okay, we have absolute value because, and if this is true, right? I'm going to write it just a little bit longer, okay? If this is true, then what? This guy is equal to that. right? We cover that very, very big time. So if this is true, then this is true, because the square root of x squared is equal to absolute value of x. Okay, and then there's another if. If this is true, what is this? This is similar to the first question in Alpha 7. What does it mean? What does this mean? If the absolute value of a number that is equals to 3, what are the possible values for x? So if this is true, of course, then we can use what we've done for Alpha 7. So if this is true, x will be either positive 3 or negative 3. So this is the complete context. This is the complete context. Okay, I know you're gonna ask me, oh, do I need to write all of these? No, you don't need to write all of these. I will give you a shorter version of this, which is the common version of how this piece of mathematics is written. Is usually it's once again it's being a shorthand notation. It's using a lot of shorthand, and a few lines is being removed. You don't need so many lines, but you need, oops, what did I do? I deleted. Okay, so let's do it again. Okay, I cannot recover this. Yeah, the undo button was canceled. Anyway, I'm sorry. So let's do this one once again. If this is true, right, then I just want you guys to follow me this one. So you learn how to read mathematics. Okay, mathematics in these kind of statement in the ifs case is always if this then that, if this then that, if this then that. It's always if then, no, nothing else. Okay, so we take square root of x squared. Okay, I don't know how I made that mistake. Okay, I meant to copy. Okay, and then if this is true, right? Another then, so the absolute value of x is equals to 3, right? And here we quoted because the square root of x squared is equals to absolute value of x. We use this truth. This is a true statement. Okay, so if this is true, then that. And then the next one will be if this is true, then what? Which is we quote Alpha 7, right? We did a similar question in Alpha 7, the first question, in fact. Okay, and then x would be either, right, positive 3 or negative 3. It's not and, it's or. Because x can only assume one value at a time. That's why it's or, it cannot be and. Do you guys follow me? We have quiz questions specifically targeting these, minor details, but yet very important details about the narratives in mathematics. This is a narrative in mathematics. This is a narrative. Okay, this is the narrative. This is the narrative. Okay, then I'm going to answer the question. Well, I assume you have this question. Do I need to write if then, if then, if then? No, you don't. You don't need to. But usually, okay, the short version of this process, okay, you remove the if because you're going to do if then, if then, if then. So, okay, then they say, well, the earlier mathematicians say, oh, well, we don't need to do the if then. We just, because we know we're going to do if then anyway, right? So we're going to do these steps. So in the end, we just trim some of those repetitive statement, repetitive words, and the shorter version is what is this, which is usually written in the textbook. Do you follow me? But when you read it, when we read this, we need to have those words mindfully in our head. This means if then, if this is true, then this is true. If this is true, then this is true. If this is true, then this is true. Do you follow me? This is how we read this language. This language of mathematics, we call it mathematics, is a highly shorthanded language. If you don't have these concepts with you, you don't have these connective words in your mind, it's very difficult to understand. Well, if you don't know they are there, it is very difficult to understand. But the good news is that we only have two kinds of sentences. One is a statement and the other one is if statement. So in solving equation case, it's just a sequence of if statement. Okay, in the statement case, of course, we're gonna, we will learn that as well. We have learned some before, prior to this, and we're gonna learn some more. So these two kind of statement we're learning through this semester is just sometimes it's statement, sometimes it's statement, sometimes it's statement, sometimes a statement turned into if statement under certain condition. Do you follow me? Okay. In order to help us understand, to help our student to understand that from here, because as I addressed earlier, some people, okay, some of you might have learned this. Okay? Some of you might have learned this with these two steps removed. Okay, from this step, okay, if you say if this is true, then this is true. Are these okay? The answer is yes. These two steps, logically, okay, it's more or less like, it's more like, okay, I'm doing, if A lead me to B, and B lead me to C, and C lead me to D, and D lead me to E, I can say A to E. Do you follow me? Logically. If A then B, if B then C, C then D, D then E, then I can say if A then E. Do you follow me? So some of these steps were skipped. Some of these steps is skipped. So in this case, if you skip these two steps, and your statement is A to E, and that's a correct statement, you will get 2 points. You follow me? However, if you also show me these steps, if you show me these intermediate steps, like this, okay? From here to that step, okay, you have applied, okay, I usually put it on this side. Okay, you have applied. Okay, this is very important. Everybody need to get this, okay? Because this is going to be how I grade your work. This is going to be how, this is be the guideline, how I grade your work. So here, I see the student have applied this principle, this true statement. Over here. Okay, this will add 2 points to your, this will add 2 points to this question. A same question. If you only did this, you get a total of 2 points. Okay, you get a total of 2 points. You get a total of 2 points. But if you have also done this, okay, from square root of x equals to absolute value of x, you recognize that is true and you apply it, you get 2 points, 2 additional points. And from here to this point, of course, this step is pretty trivial, but sometimes you're dealing with like a square root of 12, square root of 18, that requires some, additional work. You are going to get extra 1 point. And of course, for the right answer, you get 2 points. Do you follow me? So if you do this version, the total number of points you get is 5 points. But if you do this version, you're not wrong. You get only 2 points. Do you follow me? And this is my rubrics for this entire semester. And this is going to be the rubrics for future courses, such as, pre-calculus, trigonometry classes, if you happen to take those classes, mine, and I will be consistent on this. Do you follow me? Why? The reason why I impose these is to reward you, okay? Is to reward you and also to not only to reward you for using this very important fact, okay, is to primarily to reward you using this fact. Okay, that's one reason. And the other reason, okay, reason for the 5 points version. 2 reasons. Number one, reinforcing this. Reinforce this. This is number one common mistake at a college level across nation boundary. Okay, across nation boundaries. So to reinforce this and credit you for doing the right thing is important for me. So I give extra 2 points to reinforce this. Okay, by reward. Secondly, avoid mistake such as, okay, avoid mistakes such as variety of mistakes, such as this. Avoid mistakes such as square root of 9 equals to plus minus 3. Avoid mistakes such as these. So there's 2 reasons for this. Do you guys follow me? Okay, so next, so as long as you start to, you continue to take class with me this semester, and this is the rubrics whenever. Okay, I say whenever because you're going to see this kind of question gets more and more complicated. Okay, we're going to use this actually for quite a while. Okay, so next I want you to practice this version. Okay, could you please practice this version? Practice this short version of it. Okay, so please practice this short version. Please try number 2 on Alpha 9. Do you think 2 minutes might be enough for you? Solve for x equals to 16. Everybody, please practice this short version of it, okay? As again, I acknowledge some of you might have learned it this way, and that way was not wrong, but 2 steps were missing in between. And it also could give us a false impression of these mistakes, okay? So I want you guys to do this. You get more points, and you also get to reinforce that critical identity. X squared equals 16. Okay. Okay, so now here are the steps. You done? Okay, so when I grade your work, this part will be 2 points. Okay, and this part is 1 point. From root 16 to 4, that's 1 point. Okay, and the last step, which is from root absolute value of x to 4, from here to there, and that's 2 more points. So that's 2 more points. So this question, you will earn a minimum of 5 points. If you do the shorter version, okay, I just want to make sure you're clear about this. Okay, so you have a choice. If you want to use you still want to follow what you learned before, right? I assume you understand everything, but you just didn't want to show it, right? But if you solve it this way, you are absolutely right. However, you're only getting 2 points. Is that clear, everybody?
Yes.
Okay, so this is the rubrics, and I will be grading your work for the entire semester and beyond for this type of question, Okay, so it's your choice. It's your choice. Okay, all right, so let's continue with some other interesting questions. Okay, for example, number three. We try number three. Number three. We have x squared equals to 8. Okay. If that is true, if this is true, you see I'm using the if in my statement, then I'm using the shorter version of it. And then I'm going to apply the absolute value because root of x squared is equal to absolute value of x, and that equals to 2 times square root of 2. And last but not least, we're getting x equals to plus minus 2 times square root of 2. Okay, the same rubrics. Is that clear, everybody? Is that clear, everybody?
Yeah.
Okay, one more example for number 7. Okay, so we have x squared, but x squared equals 0. In this case, you really don't need to go through that square root and stuff. Okay, because a number time itself is 0, the number must be 0. Okay. If you still want to go through those steps, I will be consistent and I will still give you the credit due, but you really don't need to. It's x equals 0. So if you want to do that, it's optional. But if you do, every time you do, you will be awarded because we really want to enforce. We really want to enforce this. Top mistake of all time. So we want to enforce the, the top mistake. Of all times in math. I'm making that claim, even though I suspect that is the case, and I actually don't have the hard evidence for it. But the fact that the calculus author, who's a very popular author, and he named this number 1 mistake, and I think there must be a very good reason behind he's doing that. Okay, so this is a top mistake. So this is a top mistake of all times in math. So we want to enforce that so you don't make that mistake again. Okay. With all these said and done, let's prep. You can see that in alpha 9, we get to do, square root of 48, square root of 12, square root of 50. So alpha 10 is for you to practice those kind of simplifying things, simplify radicals. Okay, so let's look at alpha 10. See, alpha 10, they're not if statement, they're just statement. Okay, and what kind of statement is that? For example, okay, it says simplify. It doesn't say solve for. It doesn't say solve for. When it says simplify, it is just a statement. Or you probably have learned that before, it's called an expression. Okay, so what does it say? For example, okay, square root 12. Square root 12, what is the meaning? We talk about the meaning of the symbol, right? It's the positive square root for 12, not the square root of 12. You follow me? Because we talk about that, right? Root of 9 is 3, not a positive 3 or negative 3, because we know the roots will show up in pairs. One positive, one the other was negative. You find one, you find the other. So you don't need to, okay? So the meaning is, so these are just statements. All of these are just statements. And we simplify these statements. Or statements. You just simplify them and write them in another way. Write them in another way. For example, right? Root 12. How do we simplify that? How do we simplify that? Well, root 12 is equals to root 6 times root 2. It is also equals to root 4 times root 3. Why not root 6? Why not root 6 times root 2? Why not that? Well, because none of 6 or 2 are perfect squares. 4 is a perfect square. Okay, 4 is a perfect square. 4 is a perfect square. Okay, in other words, 4 can be written as another number squared. That's perfect square. And we recognize the perfect square in here, and we can reduce it to 2 times right equals 3. Do you follow me? So next, I want you guys to try a few, okay? So please try some in alpha, try some here. Okay, choose 3, choose any 3 of your choice. Choose any 3. Okay, I'm asking you to choose any 3. I hope you will choose 3 hard ones that appear, 3 hard ones that appear to you. Okay, so I'm going to give you a couple minutes and I'm going to go wash my hands. I'll be right back. Okay, I'll be right back. Okay, so choose some here, and here I'm asking you to choose any 3 and to work on. Okay, and I will be right back. Do you guys know what I'm talking about? You have alpha 10 in front of you? You guys have alpha 10 in front of you?
Yes.
Okay, you can choose any 3. Okay, any 3. Okay, Okay, guys, how's it going? Do you want to work some together?
Can we try number 3?
Sure. Number 3 is root 25, which is equals to 5, isn't it?
Is it just that though?
I'm sorry?
It's just that though? There's like no more steps to that?
Yeah. That's it. Root 25 is 5. This is not an if statement. This is just a statement, okay? You're basically you're given something, okay, to simplify. Simplify means you give something equivalent but simpler. So you basically tell the reader the root of 25 is the same as 5. Excuse me. The root of 25 is the same as 5. The sentence are dramatic, well, they're fundamentally different from the kind of sentences we work here. These are solving for, okay, you guys, for those of you who might be a little bit confused, we only have 2 kinds of statements in mathematics, okay? One is if statement, one is not if statement. If it's an if statement, you will know because it will be using the title such as if or solve for. Do you follow me?
Yes.
And here there's no solve for. It's just to simplify. You basically say, okay, root of 25 is the same as 5. That's it. Next one. Anybody who's confused, please let me help you to clarify. 2 kinds of statement. Only 2 kinds of statement in math, no more. If in the future you found the 3rd kind, please come back to see me and let me know. I would like to learn from you. In the future, some of you are going to be doing computer science. You will see in computer science, there are only 2 kinds of statement also. One is the if statement, one is the statement. Statement or if statement, that's all. And some of you are going to learn, all kinds of fancy, programming languages in the future. Guess what? Only 2 kinds of sentences. Statement or if statement. Of course, in those specific language, they don't call it a statement, they call it assignment. Okay, they call it assignment. Or if. Okay, if in various forms. Okay, next one. I hope I have made it simple for you. Yes, only 2 kinds of statements. So today we're doing some if statement, we're doing some non-if statement. Just statement. Is there another one you want to work? You want us to work together? They're all easy for you? I'm certainly happy to hear that, but I'm always happy to help. I'm always happy to help.
For number 4, is the answer 2 square root of 5?
Perfect. That's right. Square root of 20 right? I assume you probably have done this. 20 equals 10 times 2 equals to 4 times 5. You don't use 10 times 2 because none of them is perfect square. You use 4, 5, right? You use 4, 5. And then 4 is a perfect square, so you can take it out. You get 2 times square root of 5. Very good job. Very good job. Does everybody follow me? All of these are statements. It's just statements. Okay, and they tell you to simplify, basically say to give you exactly the same answer, but in a simpler form. That's what it means. So you will reduce it as much as possible. Then you say, well, these days and time, we use a lot of calculators, right? Well, just punching the calculator. Why do I have to go do this? Well, guess what? All the professors you are going to see in El Camino College or Santa Monica College, or you go into four-year schools and you see those, math professors, engineering professors, and they're in these different departments. Okay, all professors in four-year schools, in community colleges, they expect you to be able to do something like this. Do you follow me? Do you follow me?
Yes, Professor.
Okay, you want to get points from them and just do what they want. Okay, this is checking on your basic math skills. Basic math skills. Okay, so the basic math skills does not include the use of calculator. With the exception, probably, you're taking a statistic class. But in statistic class, most of schools these days, they will guide you to use some sort of specific software. So the handling of software, which is another programming language, right? These are the skills that you really need. So punching in calculator, being able to use a calculator, punching numbers is not considered an essential skill. And because that skill, everybody can do it, right? Everybody can do it. So it's no longer a special skill. Being able to handle these things will be considered some kind of worthwhile skill. Okay, so I personally don't dictate this, but it is a common denominator for all the math professors who are teaching in this field, or professors in engineering department, in the whatever department that related to math. They all expect you to do this. Can I change that? No, I cannot. I don't have that much power to change it. Can you change that? I don't think so. Okay, just accept it and make yourself better at this, right? And you can see after you do, number of questions, it's no longer that hard anymore. And here I'm helping you and I clarify, hopefully. You got the hang of it?
Yes, Professor.
Good, good, very good. Is there any other question you want me to go over? Okay, so if you can handle all of them, you understand that you can ask me questions anytime. I want to move forward to alpha 11. Let's see what's alpha 11. What is alpha 11? Alpha 11, actually, okay, if you see the setup of alpha 11, okay, so I'm going to show the screen of alpha 11, and knowing every one of you have that in front of you, but I'm going to make some point on alpha 11. Alpha 11. On alpha 11, you can see the top. The first row, I refer to the three types of equations, or the three type of, they're all if statement for sure. They're all if statement for sure. Okay, they're all if statement for sure. But they all refer to alpha 7, alpha 8, alpha 9. Alpha 789. Do you guys follow me? Alpha 789. Alpha 7, alpha 8, alpha 9. 7, 8, 9. I switched the order, but for good reason. Okay, for good reason. What happens here? Here, that if statement, this x, okay, this x, you know, what I'm gonna do is I'm gonna give you another screen. Okay, so I want you to look at this screen. Okay, I want you to look at this screen. I'm gonna go back to another screen. I want you to see this evolving mathematical contraction. Okay, I want you to see this mathematical abstraction. You see, oh, there's really nothing to it. There's really nothing to it. Okay, so just 1 second. Okay, I still want to go back to this screen. Okay, and I'm going to make something simulating. One is square root of x equals to 5, right? That's the first question in alpha 11a. And the second one, which is similar to alpha 7, which is equals to 5. And the last one is x squared equals to 5. Okay. The next row, okay, if you look at 4 basically is seeing x as baloney. I'm going to call it baloney, whatever that's. I know that symbol is called omega, but I'm going to call it baloney. You can see these two forms are the same, aren't they? Are they the same? Do you guys follow me? Are these two forms the same? They are, right? Whether I put 6 there, I put a 9 there, I put anything there, they're the same form. But this x is turned into baloney, and this baloney is turning into x plus 1. So these two are really still the same form. Do you follow me? Yes?
Yes.
What I want you to see is that there are different forms. They're different form, but they're all same type of question. Do you guys follow me? The first column, they're all the same type of question. It's just that that baloney, it turned into various things, turn into various more complicated algebraic forms. Do you follow me? They turn into more complicated situation, but they're really all the same type. That's the first column, the type of alpha 8. Okay. The second column, you see the same transformation as well. Okay. It's not these two rows have anything related. They're not consequential in any way, but they're the same form. So if I see this as omega, or I call it baloney, and this baloney turn into what? X plus 1. And these two if statements are similar statement, aren't they? Same form. So we call them the same type. So it's more like you classify question, these if statement, right? This is if statement regarding square root, and this is if statement regarding absolute value, and this is if statement for x squared. Do you follow me? So you have 3 folders. So we have 3 folders here, and the first folder, we keep all the square root together. The second folder, we have all the if statement about absolute value together, and the third statement, we have all these squares together. Got it? And the way we handle them will be similar to what we did with alpha 7, 8, 9. Do you follow me? So that's the power of understanding how to handle a specific types of questions. So let's look at the third one. Okay, the third one is turning to baloney as well. right? So instead of, we change it to omega squared equals to 12. And then we move 12 to the other side. Do you follow me? So you can transform it in all different ways, but they're really the same type. They just one day, this person wears a red suit, and the next day, and this person is going to wear a dress, wearing a dress. There's all kind of various form you can get using the 6 principles, in particular the first, second, third, and fourth. You follow me? And they're all if statement. They're all if statement. They're all if statements. Okay, so if, and we have 3 folders. Okay, so let's look at the graph. Okay, I wish to, from the graphic perspective, right? From the graphic perspective, the graph of root x, we know the graph, don't we? What is the graph of root x? Do you guys know the graph? Do you know the domain and range? Could you guys show me? That's the graph. Right, that's the graph. That's the graph. And what does it mean? What does this if statement mean? If the square root of x equals to 5, what does that mean? 5. What is the crossing? We know the output, we want to find the input. Okay, so let me make just make some quick adjustment. Oh, have okay. That's the meaning. Remember we talked about these before, right? We talked about these before. If the output is 5, what is the input? What are all the possible input? Now let's look at this one, absolute value of x. What is the graph of absolute value of x? We know the graph of absolute value of x. Do we know that? Everybody should know that. I'm sure you do. What's going on here? Okay, hold on. I'm going to just put this. I think the software sometimes is a little bit confused because I have so much demand, right? I demanded so much. So what I'm going to do here, let's see, that will graph it for me. This time it's not as confused. Right, so that if statement means if the absolute value of x is 5. So we're going to add a 5 crossing. Okay, and I'm going to make some adjustment. So what I want you to see, is the consistency in meaning. Consistency in meaning. Just different forms. Okay. Right here. Where the crossing? If the output is 5, what is the input? Last but not least, for x squared. We all know the curve for x squared, don't we? Everybody does. So we want to understand the meaning thoroughly, absolutely thoroughly. Okay, so I'm going to make this, just make some adjustments so you can see the picture. Okay. And the crossing is 5. I'm going to make this just a little bit narrower. It doesn't matter, but you can see this clearly. Do you follow me? Do you follow me? If okay, whatever the rule, okay, whatever the rule, your rule could be square root of x, it could be absolute value of x, it could be x squared, it doesn't matter what the rule. Okay, you have input and you have output. Okay, the only difference is all these 3 rules, they have different, there's 3 different rules. We have the same output, the output are 5. Okay, so that if statement can also be read as, if the output is 5, what are the inputs? Give me all the inputs, please, give me all the inputs. Come on, give me all the inputs. Such that the outputs are 5. Do you follow me? Do you see that consistency meaning? You see, this class is about meaning, understanding, consistency. Okay. All right. So now, any questions so far? Any questions so far?
No questions.
Good, good. Well, if you have any questions, please don't hesitate. Okay, I'm not saying no question is good. I'm saying at this moment, I assume that you guys understand. You understand that's really good. Okay, so next, let's look at, do you see the consistency, don't you? Do you see the consistency? Absolutely, absolutely. Okay, if statement, if the output is 5, right? It's if statement. And if output is 5, right? If the output is 5, if output is 5, right? If output is 5, give all possible input. Could be plural. It could be plural. Okay, so let me make this just a little bit smaller so you see the whole thing. Consistency. So this is summarized 7, 8, 9, and we're going to move on with 10. We're going to move on with 10. Okay, so we're going to take a break. We're going to take a break for 10 minutes. Okay, right now it's 11:36. So please come back. Please come back. Okay, please come back at 11:46. Okay, so please come back at 11:46 and we'll continue as how we process it. Okay, how we process these same types. Okay, I'll see you guys in 10 minutes. Okay, everybody, welcome back. you can see that we want to thoroughly understand the meanings. Only if we understand the meanings, then we can deal with any questions of this sort, or even question you never saw, we never seen before, but you'll be able to figure out, from the rule, from input, from output, and so on and so forth. The other very important facts that we need to know that the solution should always be in the domain. Okay, the solution should always be in the domain. Remember, we studied the domain for these different rules, right? Could you tell me what the domain of this rule, of these rules? What is the domain for f of x equals to root of x? What is the domain? Okay, let me, I put these together. So it's for convenience. Okay, what is the domain for square root of x? You can go back to your notes and find out. What is the domain? I'm waiting for your answer. What is the domain? The picture tells us the domain, right? Does the picture tell us the domain? Where do we have pictures? What is the horizontal span of this picture? From 0 to infinity, isn't it? Does everybody follow me?
Yes.
So the domain is what? X greater than or equals to 0. So the domain is horizontal span. So the horizontally, you see the picture from 0 to positive infinity. And what is the range? The picture also tells us from 0 to infinity, right? We've learned that from alpha 4, isn't it? I think that was alpha 4. Is that alpha 4? I believe so. Alpha 4. Do you guys follow me? So all we learn, everything we learn from the beginning to now this point, they're all connected. None of them is it's just an outlier. It has nothing to do with anything else. Two kinds of statements. If you follow these meanings and understand these two kinds of statements, you always will have some clue as what to do. Usually, okay, with adequate mathematical basic skills. Okay, so now square root of x, its meaning is that if the output is 5, for this rule, then the crossing is the answer. And this answer has to be what? This answer has to be, we know the answer. What is the answer? We have learned how to do these kind of questions, right? The answer is what? 25. Right? The answer is 25. Now we turn this into bologna. Right? We turn this to bologna. And what will be the answer to that square root of bologna? Equals to, if the output is 5. Well, the bologna will be 25, isn't it? Do you guys follow me? And what if that bologna is x plus 1? Then x plus 1 will be 25. Do you guys see the same form? So we have a certain routine to follow. Does that make sense? And now the question is, if x plus 1 equals 25, what is x? What is x? X will be 24, right? Just subtract 1 on both sides using principle number 3. So do you guys get my idea? Understand the whole thing? The graph, the function, and how it's been related to domain and range. Okay, so we're going to see more examples. Now, look at the second column. The second column, we have a different rule. This different rule is the absolute value of x. Okay, and what is the domain for absolute value of x? What is the domain? What is the domain? Let's see who can help me who could tell me what is the domain? Francisco? What is the domain for absolute value of x? Feel free to look at the notes and stuff. Marcelo? Marilyn?
Infinity.
Anna? What is the domain? What is the domain?
X is greater than or equal to 0.
X is greater than or equal to 0. You mean only on this part? So how come we have pictured on the negative side of x? Brianna, what is the domain? We covered that in Alpha 4, right? So go back there to look at the notes. Go back there to look at the notes. When we consider absolute value, what can be the input for absolute value for that rule? It can be negative number, can be 0, can be positive, right? So the domain is what? All real numbers. Can be any real number. Okay, the picture shows the graph goes in this direction forever. So that means horizontally you can go from negative infinity to positive infinity. How about the range? The absolute value of any real number is always greater than or equal to 0, right? So the absolute value of any number is always greater than or equal to 0. That's the range from 0 to infinity inclusive. Okay, so that's what this picture tells us. Okay, and if f of x equals to 5, so that's, you draw a horizontal line, you cut the curve, and you cross it at 2 places. So you're going to have 2 input, these 2 input. And what are the 2 inputs? So here, suppose this is x. What are the solutions? We did this in alpha was it alpha 7, right? Alpha 7. I think it's either alpha 7 or alpha 6. I believe it's alpha 7. What is the answer for absolute value of x equals to 5?
Positive or negative 5?
That's right. Excellent. Plus 5 or minus 5. Right? Because these 2 input, negative 5 will make it true, positive 5 will make it true. Input a negative 5 will make it a positive, output 5. Input a positive 5 will make it output positive 5. That's right. Now this turned into baloney. same drill. Right? And the bologna would be plus minus 5, right? Will be 5 or negative 5, yes? So this bologna is going to be positive 5 or negative 5. And what if the bologna is x plus 1? So x plus 1 would be positive 5 or negative 5. Do you follow me? And dropped with the absolute value sign dropped. With the absolute value sign dropped. It basically said if the absolute value of x plus, if the absolute value of this bologna is 5, then this bologna could be 5 or negative 5. If we write it in an expanded form, which is going to be x plus 1 equals negative 5 or x plus 1 equals to 5. And we solve each individual equation, and what do we get? We'll get x equals to negative 6 or x equals to 4. Where we use principle number 3, mathematical principle number 3. Sorry. Do you guys follow me? Do you guys follow me? Okay, you can see the same ideas, the same treatment. The only thing that's different is the rules are different. Okay, some rules are taking square root, some rules are taking absolute value, some rules taking, the input and multiply itself. But the ideas are similar. The structure of the sentences are similar. And all the solutions are going to be in the domain. Okay, what the domain and range for? Okay, you're gonna see more on what the domain and range for. All right, so let's look at the third column. Okay, and this time, what is the rule? The rule has changed to be x squared. Right, the rule has changed. What is the domain for range for this one? What is the domain? What's the domain for x squared, for f of x equals x squared? What is the domain for that rule? What is the domain for that rule? What is the domain for this rule? With that graph we did in AlphaFour. Domain and range, go find out, please. Francisco, what is the domain? What is the domain? Marcelo, what is the domain? Alan, what is the domain?
All real numbers.
Perfect answer. Perfect answer. What is the range? You see the curve is above x-axis, right? It will never be negative. So the range is what? A number time itself is always
Greater than or equal to 0, yeah.
Perfect answer. Perfect answer. Okay, so how did we solve this kind of equation? We did that today, right? How did we solve that equation? Okay, suppose we didn't have that. We didn't have 12. We just have equals to 5. What would you be doing? We have those few steps, right? Few steps. See, let's do it. Okay, suppose this is bologna. Okay, same form. So what do we do here? We're going to take square root on both sides. Remember, this is an if statement, right? If the output is 5, we want to find the input. So if that is true, we take square root on both sides. And this will be the absolute value of omega or bologna. That will be equals to square root of 5. Right? And then for this absolute value equation, that if the absolute value of this bologna is square root of 5, what would be that bologna? What that bologna would be? Positive or negative? Square root of 5. Do these steps look familiar? Do these steps look familiar? Do they look familiar? Right?
Yeah.
Seen that many times. So now let's make some changes. Now it turned into minus 12 equals 0. Right? And these are x's. Well, I'm just going to add a 12 on both sides. So I will get an x squared equals to 12, right? So this is going to be what? This is going to be x squared equals square root of 12. And square root of 12 can be reduced into 2 times root 3. Yes? And this is x. And this has become 2 times root 3 of 12, 2 times root 3. And in the end, x equals what? Positive or negative 2 times. Do you see the similarity? Do you see that these 3 models we learned at 7, 8, 9, they become a little bit, they're applying to a little bit more complicated situations. Do you see that? So all the x's we done in 7, 8, 9, they turn into what? They turn into bologna. They can turn into a slightly more complicated entities. That's what I want to show you in front of your eyes. Did you see that? Yes? Do you follow me?
Yes, Professor.
Last statement before we move on, before you practice. I just made a statement earlier on, right? I just made a very important statement earlier on. All the solutions to these if statements, okay? All the solutions to if statement, all solutions about input must be in the domain. I'm sorry about the blinking. I didn't make that happen. I didn't do anything. All the solution must be in the input. Is 24 in the domain? Yes, the domain is greater than or equal to 0. 24 is in there. And the domain for absolute value of x are all real numbers. So the solution here, they're in the domain. So I'm going to put I'm going to put this statement under here. Okay, I think that'll be fitting. Okay, all the solutions about the input, right? So when output is given, we're looking for input, and all the output, if the output is given, the output must be in the range. Okay, the output must be in the range. If it's about output, okay. If output is given, output must be in the range. So this is the power of a domain and range. It allows us to check if your solution is in a domain or the solution is in range. You follow me? We are given an output 5. Is output in the range of all 3 functions, all 3 rules. Does it? It does, right? The range for square root of x is greater than or equal to 0, and 5 is in there. And the range for absolute value of x is greater than or equal to 0, and 5 is in there. And the range for x squared for this rule is positive or 0, and 5 is in there too. So the output given is also in the range. Okay, the output must be in the range. Okay, the output must be in the range. Now we have done 3 types. I want you guys to try something, try your hands on this. Okay, and reflecting on these meanings. Okay, reflect on these meanings, the graph, the function, domain, and range. I have to say this is a lot. This is a lot of information. You probably didn't learn algebra, intermediate algebra before this way, but I think this way probably is better for us. Okay, instead of picking up bits and pieces in different places, now you have everything just together. Rule is a statement or if statement. It could be input given, could be output given. And input must be in the domain, output must be in the range. That's all. Okay. So now I want you guys to try the third row. The third row, get a piece of paper. Okay, get a piece of paper, pencil. And work on alpha 11A. Okay, I want you guys to work on the third row. The third row. The third row. Okay, I'm gonna leave the answer right here so you can see. Try the third row. You can continue to build that table where you just have 3 other columns. What I wish you reflect on is what we just have done and illustrated. Okay, what we have done is illustrated. 3 types. Put yourself in that context, okay? Context of the statement. If statement, you put yourself in the if statement. All right, how you're doing? You get a hang of it? You can see the numbers start to change, right? Numbers start to get a little bit more and more complicated. The bologna gets a little bit more complicated, but you start to get a hang of it, do you? So over here is going to be x minus 2 is going to be equals to 25. And the next one would be x equals to 27. And is it 27 in the domain? Yes, absolutely. The domain of, okay, we're going to talk about the domain of x minus 2 though. The domain of x minus 2 actually is not only positive, it's going to be a little smaller. Okay, but this 27 definitely is in the domain of square root of x minus 2. I'm going to talk about, I will address domain later. Okay, we'll address domain later about this. Later, okay, on this one. Okay, we will address the domain on this one just a little bit later. Now, these two, the domain is not an issue. They're all real numbers, so we don't need to worry about. Okay, so you can see you're going to get x minus 2 equals to negative of root 5. Okay, or x minus 2 equals to positive of root 5. And then you're going to get two solutions. Okay, so x equals to 2 minus, you subtract 2, you're going to add a 2 on both sides, not subtracting 2, I'm sorry. Okay, you're going to add a 2 on both sides. And or you get the other one. Two plus square root of 2. And you can also write it this way. It's 2 plus minus square root of 2. Or square root of 5. Sorry, I'm my bad. Sorry about that. Okay, and you can condense these steps into that. Okay. Okay. You can also write it in a slightly different way, which I'm going to show you momentarily. And this latter one, this is the last one. Okay, you're going to take square root on both sides. And there are some variations I will show you. Square root. And this is going to be square root of 3. Okay, then you end up with absolute value of x minus 2. And that equals to square root of 3. Okay, and you can write it as x minus 2 equals to plus minus the square root of 3. And in the end, you can write x equals to 2 plus minus square root of 3. Okay. In these two cases, because the consideration of bologna, the picture will all have some kind of shifting taking place. Okay, they will all have some kind of shifting taking place. Okay, because these rules have changed, because the rule has changed. Okay, so I'm going to demonstrate the changed rule. I'm going to demonstrate to you the changed rule. Okay, so let's see how the changed rule has, how did that happen? Okay, this rule, that was absolute square root of x. And now it's the square root of x minus 2. What's the difference? And certainly these rules are different. The rule has changed. Okay, so this rule says you're going to have a new function. And this function, of course, taking numbers, and it gives output. And it will have a new domain. It will have a new domain. Okay, and the output is, of course, root x minus 2. Okay, you can see there's a slight change of the rule. I take the input, I subtract 2 before I take the square root. Okay, and what is the consequence in graph? Okay, so I'm gonna go over that with you. Okay. Because we take square root, so x minus 2 has to be positive or 0. It cannot be negative. So x minus 2 has to be greater than or equal to 0. So this domain is going to be x greater than or equals to 2. If you look at the picture, this picture is going to be changed slightly. Okay, so this time is going to be x minus 2. Okay, so the view is going to be from, it should be like that, that's fine. Okay, it's a little bit shifted. It's a little bit shifted. If you compare the previous picture, if you compare with the previous picture, okay, the new picture, okay, the new picture. So if I change it to a different color, okay, do you guys see that picture? The black one was the old picture, okay, square root of x. The square root of x minus 2 is a shifted picture. It's shifted. And that crossing 5. Crossing 5 is still the same idea. It's just this curve is shifting, it's shifted. So now we are addressing this domain. So this new domain, the new domain for this function in consideration for the change the rule, and this domain will be here. That's the domain. Do you guys follow me? Do you get the note? Does everybody follow me?
Yes.
Okay. So how about this one? How about the second one? Well, it's still all real numbers, but there's still a little shifting taking place. Okay, so this picture is going to be shifted. Okay, so for this new rule, the picture is going to be shifted. Okay, we're going to talk about shifting of pictures in the future. So right now, we're not doing that. We're not doing that. But I still give you some ideas about it. You can see the new picture is shifted to the right, actually by two units. But the crossing with root 5 is still the same. It's still crossing. Of course, I'm going to put a root 5 here. Okay, instead of 5, it's a square root of 5. Okay, the shifting idea hasn't changed. I'm sorry, you know, the crossing hasn't changed. It's just crossing the red one. Okay, and let's look at x minus 2. Does this picture, what is this rule? This rule certainly has changed as well, right? This rule certainly has changed as well. Right? So there's rule change. Okay, so this rule changed to, okay, the function's rule changed, and its absolute value of x minus 2. And with that rule change, the output will change. We will be addressing the shifting of curves, but you can see the shifting takes place obviously, okay? So the domain is still all real numbers. The domain is still all real numbers still. When these kind of shifting, the domain hasn't changed. Last one, x minus 2 squared, right? And this rule has a slight change, right? It still takes the input and it produces output, right? And the domain is still all real numbers, but you're going to see the shift of a picture. Follow me? So this picture is shifted. Okay, and you are going to see that shift. You're going to see that shift. And of course, now it's not 5, it's going to be 3. So I'm going to show you that shifted picture, x minus 2 squared. And that is being shifted to the red one. And it's no longer 5, it's a 3. There you go. You follow me? You see that the rule has a minor change, because instead of doing x squared, now we're doing x minus 2 squared. We first do x minus 2 and then squared. As a consequence, the curve is shifting. All 3 curves you can see, the red curve, they're all shifted. You see it's become x minus 2, input is x minus, take the input minus 2, take the input minus 2, take the input minus 2. So all 3 curves are shifting horizontally by 2 units to the right. Do you follow me? Does everybody follow me? So there's a slight change of rule, and there's a slight change in domain, and these other 2, the domain don't change. Shifting takes place. And so all of these functions we work with here, alpha 11a, they all have these, subtle change. They all have these subtle changes. They all have these subtle changes. Sometimes it's shifting to the left, sometimes it's shifting to the right. Sometimes it's shifting up, sometimes it's shifting down. But the basic ideas have been the same. The basic ideas have been the same. Did you write that down? Did you guys write it down? Isn't that interesting? Anybody who is a little bit confused, let me know if you're a little bit confused. Rule change. Rule change. Any questions? Any questions? Any questions? No?
No, I'm good.
Everybody? Everybody? You see, when the rule changes, your curve changes. The domain and range may be affected. Domain and range may be affected. Absolutely, domain and range may be affected. Yes, the recording will be automatically available after it's available in Canvas, in Tech, in Tech Connect. Let me show you. Okay, so let's just take a brief tour. Okay, I'll show you where to see the recording. Okay, it may not be immediately available. It may not be immediately available. Let's see, where's that page? Over here. Yes. Okay. You see, this is the classroom. This is going to be your Canvas page. Okay, so I'm going to show you your Canvas page. You see that? This is your Canvas page. So what you're going to do, you're going to connect Zoom. After class, it may not be immediately available. but it's going to be available soon. So you're going to click on cloud recording. Cloud recording. On cloud recording, all the past lectures are being posted here. So you just have to click them. Okay. The latest one that's available is last Wednesday. So today's recording will be available soon. Usually, I don't think it takes very long. Zoom is pretty good. Okay, Zoom is pretty good as for the availabilities. Okay, did I answer your question, Marcelo? Okay, so that's where you find them. Okay, all right, so let's come back. Let's come back to our, there's a lot of contents we have covered here. Okay, normally these contents will be covered in different chapters. Here and there are scattered. I bring them together, so you will see an integrated part of this whole, just one question with different aspects. Okay, so next I would like you guys to try the next row, and we're going to see the shifting taking place. Okay, so let's look at the shifting. Okay, the next row is x plus 3, x plus 3, x plus 3. Okay, let's see what's going to happen then. Okay, x plus 3. These rules are being modified for sure, right? So I'm gonna create another 3 columns, but still have some continuation. Okay, the basic rules, basic functions, the basic ideas, right? With these models, and certainly I've changed that to 3. So this is a 3. And that one is changed to 3. Okay, these numbers, you know, it varies from one to the other. So this one changed to 9. This is changed to 9. And I'm going to make some adjustment over here. Okay, so you can see the ideas. Okay, and next we're going to look at question number 10, 11, 12. 10, 11, 12. Are you guys looking at 10, 11, 12 on Alpha 11? 10, 11, 12. I'm going to insert some rows. This time the rule has changed. The rule has changed. Okay, is square root of x plus 3. Okay. All right, so f of x. And the other one, we're still using f of x equals to, each column, they're independent of the rest, okay? So I hope that that doesn't cause any confusion. And this is going to be x plus 3. And f of x, the last one, is going to be x plus 3 squared. X plus 3 squared. Okay, and of course we have that if statement. If this guy, if this output is what? If that output is 0, okay, input, what should be the input? Right, the second question. And this one, the new rule, this is a new rule. You can see the rule has changed. right? We want the output to be what? We want the output to be, hold on, root 2, square root of 2. Okay, the last column, we still have these rules, but it's a slightly new rule. And the output is 5. Okay, and that's what this equation is about, right? That's what we're solving for. So if the output is 0, give me the input. If the output is square root of 2, give me the input. Okay, for different rules. If the output is 5, give me the input. You guys see that consistency? It's just different rules, and you speak with the same kind of structures of sentences, don't you? You follow me? Just slightly different rules. Let's look at the graph. Let's look at the graph. Okay, so let's look at the graph. Let's look at the graph. This is x squared, right? This was x squared. And after we do this x plus 3, it's a new graph. There's a new graph. There's a new graph. It's the square root of x plus 3. And what happened there? What happened there? The graph is shifted. The graph is shifted. Okay. So I'm going to give you a better view. I'm going to give you a better view. And I also I will show the new graph with different color. You see the new graph for square root of x plus 3, that graph is shifted to the left by 3 units. Plus 3 shifted left by 3 units. You guys see that? You guys see that? Everybody. Right? The last picture when we did x minus 2, all 3 different rules, they shifted right by 2 units. Minus 2, shift to the right. Plus 3, shift to the left for this one. Is it going to be shifting to the left for the second one as well? Do you guys see patterns? Do we see patterns? So now this is going to be x plus 3. Okay, we're going to make it red. And let's see what happens here. It shifted to the left by 3 units as well. It's also shifted to the left. And the last one. Sorry. The last one. Let's see where it shifts to. I want to give you an educated, I want you to guess, which direction do you think this last one will shift to? Left or right? You guys follow me? Does it shift to the left or is it shift to the right? I want you to guess before I plot. You can plot using your calculator if you have a graphing calculator. The other 2 shifted to the left because of x plus 3. Will this one shift to the right or shift to the left? Give me your best guess on the chat if you wish. Where is it going to shift to? Hello, are you there? Where is this curve going to shift to? What is x plus 3? Where would this be shifting to? Left to the right? Come on, guys. To the right? This black one here, do you guys see the cursor? This black one is a square root of x. I should use a different color. Okay, I'm gonna have you guess. Okay, so I'm not gonna show you. I'm not gonna show you yet. And two of you think it's gonna shift to the right. So let me show you let me just show you a little bit more. Okay, in this picture, okay, the black curve, what is the black curve? Or 2. Okay, and make his smaller fonts. That's the black curve. Okay, do you guys see that well? Do you guys see that well? Do you guys see that? This black one. The red one, what is the red one? Do you guys follow me? X plus 3. So I'm going to put it at -2. 1. Maybe -3. Okay, I'm going to use the red color. The red is the square root of x plus 3. The black was square root of x. Relative to the black, the red one is to the left of it or to the right of it? Is it shifting to the left or shifting to the right? You guys are telling me to the right. Think again. Is it shifted to the left or shifted to the right? Come on, guys. Are you guys there? Brianna. It's shifted to the left, right? It's shifted to the left, right? Do you guys see that? Devin, is it shifted to the left or to the right? Left. Very good. Very good. Okay, so let's go back to see what we did earlier. For x minus 2, is it shift to the left or shift to the right? The black one was the square root of x, and the red one is square root of x minus 2. Where is it shift to? It shifts to the right. One is x minus 2. Do you guys see that? We're gonna do more of these in another at another time. Right now, I just want to give you guys some visual. Okay, right now I just want to give you guys some visual because we cannot do everything all at once. It's just a limited number of things all at once. So x minus 2, you can see the rule change from square root of x to square root of x minus 2. The shifting is shift to the right by 2 units. Do you guys see that? So x minus 2 is shifted to the right by 2 units. The entire picture is shifted to the right by 2 units because we changed the rule slightly. We have x minus 2 before it takes absolute value. And for x minus 2 squared, the same thing. The rule has changed slightly. Instead of doing x squared directly, we're doing x minus 2 and then square the difference. And as a result, the picture shifted to the right by 2 units. So when we have x minus 2 is shifted where? To the right by 2 units, right? And now we have x plus 3. I know this is a little hard to get to. That's why I want to give you guys some visual. Okay. In the future, we will answer the question why it is shifted to the right, why it is shifted left this way. Okay, it's a little counterintuitive, isn't it? It's a little bit counterintuitive. Do you agree with me? It's a little bit counterintuitive. So for x minus 3, it is shifted to the left. Shifted to the left. And this one is also shifted to the left. Do you guys see that? So what, in which direction will the last picture shift to? Left or right? Marcelo, do you think the last picture is going to be shift to the left or shift to the right? No answer? Or you guys are tired? Are you guys tired? So tired? Which direction do you think the red, we're going to plot another curve here for x plus 3 squared to the left. Very good. Okay, that's called an educated guess. You understand we have covered so far, so you anticipate this is going to shift to the left. Well, you may be right, may be wrong. Okay. And now it's shifted to the left. Do you guys see that? Okay, I'm going to make just a little bit adjustment. Okay, so you can see better. It's shifted. Okay, so I'm going to wait for you guys to write it down, this piece of, these two pieces. Okay, I know it's a lot of information. It's a lot of information. And we haven't solved this equation. We haven't solved these if statements yet. Okay, so we're going to solve these if statements. Okay, we're going to solve these if statements. Okay. So new picture, but still the same horizontal, the output is given. We want output to be 0. We want output to be √2. I want output to be 5. Okay, so this output, we want it to be 5. Okay, so this is going to be 5. We want it to be 5. Okay, this output, we want it to be square root of 2. Okay, instead of 3, we want square root of 2. You see all of these changes in numbers, but doesn't change the nature of the question. And this one, of course, we want it to be what? We want it to be 0. We want it to be 0. Okay, we want it to be 0. Is there any impact on domain? What's the impact on domain? All these shiftings, does it have an impact on domain? Will this impact have any, will these shifting have an impact on domain? Absolutely. You see the red curve? You see the red curve here? The domain is no longer from 0 to infinity. It's going to be from -3 to infinity. And this one is still all real numbers, right? You can see there's these shifting doesn't cause any major issues in terms of domain for the absolute value and a square, but it certainly has an impact on the absolute value on the square root. on the square root. Do you guys follow me? So this domain is impacted, but these domain were not impacted. Okay, so let's finish. Okay, I do want to finish this before we go home. Okay, before the end of the lecture today, but that shouldn't take too long. Okay, and what number you take square root is going to be 0. Well, the number has to be 0. As a result, x equals to -3. And on this one, you can just do x plus 3 equals to plus minus square root of 2. And subtracting 3 on both sides. And plus minus square root of 2. Last but not least, we're going to take square root on both sides. Remember those steps, right? We reinforced. If that is true, we take square root on both sides. That should still be true. And we have the absolute value here. We're going to impose that because we apply that absolute value of x squared is equal, well, square root of x squared is equal to absolute value of x. So that equals to square root of 5, right? And then x plus 3 is equals to plus minus square root of 5. And in the end, last but not least, x will equals to -3 plus or minus square root of 5. Okay, so these are the inputs, and that input certainly is in the domain. And this input is certainly in the domain because it can be any real number, but only this one is of concern. And guess where it is? It is in the domain. It is in the domain. When we plug in -3, we get a square root of -3 plus 3, which is square root of 0. The square root of 0 is 0. Okay, so I'm waiting for you guys to write it down. So when you study, you do a comparative study, combine with what we learned in Alpha 4. And of course, we have extended a little bit with the shifting mechanism. And we introduced the concept of Bologna. Which make first column, second column, third column, they're just like, they're the same type of questions. Okay, so today's homework will be up to Alpha 11. Okay, try all of them. I think very soon you're going to get the hang of it. Any questions?
No, I'm good, Professor.
Good, you understand? You do? I hope so.
Yeah.
Okay, of course, there are a lot of things we're going to have to we're going to have to we will elaborate in the future, but over time. But today, the picture I hope to give you is to give you some visual, and it's a little bit counterintuitive, I agree. Okay, but over time, you will understand. So this is x squared, this curve is x squared, and this red curve is going to be x plus 3. No. What am I doing? I'm plotting the wrong thing, the wrong place. Okay, I apologize. This is absolute value of x. Okay, my bad. Okay, that's absolute value of x, and that's the black, and the red. With this software, it doesn't. I have to take my time to do this. So as I'm waiting for your question, I'm going to just put these in place, okay? Do you have any questions here? I'm going to change the color to red. So hopefully this will help us to visualize. You can see the red is the absolute value after the shifting to the left. Okay, I'm going to move over just a little bit more. I'm going to make this a -3 here. Do you see the shifting? Oh, I'm still not very, okay, let me do one more time. Oh, I'm sorry, I put it in the wrong place. Let's see if this is better. Yep, this is absolute value of x plus 3. This is do you guys see that? Do you see that? This is absolute value of x. Make it larger. Absolute value of x minus x plus 3, and this is absolute value of x. I mean, this software is not perfect, really, in many ways. So, 3. Scoot over a little bit. Okay, this is better, isn't it? So the red one is absolute value. So what you see is that plus 3, they all shifted to what? To the left. It's a little bit counterintuitive. Okay, so one last attempt to make it better. Please do it for me. Okay, still, gosh, I think maybe I'm kind of a perfectionist, right? Do you guys see that very clearly? I want to give you guys that visual. Okay, last but not least, do you have any questions? Make sure you take the notes, you take a good notes. And over here, I'm going to add the x squared. And I'm going to put this 2, 5. It's italic. Okay, so that's the x squared. And the red one, I'm going to scoot over. I'm going to have it scoot over to x plus 3 squared. Make it -7. Red. And I hope this will help for you to see the comparison. This is the red one, it's x plus 3 squared. How is that? Is that helpful? It's -6 here. All right, so this is much better, isn't it? Do you see that shifting? Right, left, right. For x minus 2 is shifted to the right. For x plus 3 is shifted to the left. It's a little bit counterintuitive, okay? In the future, we will have a chance to know why and how, okay? And this is very common. This is basically it's something you learn by observation. You're gonna observe that, okay? I will see you guys on Wednesday, and I will put the homework there, and I still do expect quizzes this week. And I will see you guys on Wednesday, if not sooner. Okay, if you have any questions or need any appointment to help, to get help, that's not a problem. Okay, just reach out to me. Okay.